last class we discussing about relational algebra with the selection and projection operations, right? So discuss these two operations that are required to retrieve a data, right? Retrieve a data from a database and database. Okay. So relational algebra is a relational algebra. It's nothing but a collection of or a set of operations that use it to manipulate the entire set of relation is called relational algebra. It's a entire set of relation. It's a collection of set of operations that use it to manipulate the entire set of relation is called relational algebra. Is called an relational algebra, right? So discuss about selection and projection and combination of both selection and projection, right? For this we required a table called a company database table, that is employee, SSN, name, salary and D number. So all this one is required. All this one is required as a part of table to be required, as a part of table to be required to this to do this operations. So write employee, SSN, name, salary and D number, right? So then we have department with D number, D name and S, right? Then we have a project, P number, P name and P location with D number. So works on contains SSN, P number and hours, right? And hours. So dependence contains the SSN, dependent name and dependent relation. So these are the tables that required, right? They're required to do manipulation of these operations of like selection, projection. What I want to do next, union, interaction, intersect and minus, right? So then I want to go with Cartesian product, then I want to go with the joints. So here, as I told, last class we discussed about selection and projection. So for example, if retrieve the SSN of employees, or retrieve the tuples of a employees work for department number 2, that time we just use D number is equal to 2 from employees, okay, it is R1. So R1 contains a relation, of the tuples which the employees working for department number 2 and department number 2 will be retrieved, okay. So this is one condition that is applied as a selection condition. If we include projection condition, for example, if retrieve the SSN of employees or name of the employees working for department number 2. So retrieve the SSN working for department number 2 from employee table, you can retrieve, that is R1. So here R1 contains the employees of SSN working for department number 2. In selection, we are retrieving only the employees working for tuples working for department number 2. But when you go for projection, we want to go to retrieve the name of the employees, retrieve the name or SSN of the employees working for department number 2. There is a combination of projection and selection. So projection is retrieve the columns that required a specified condition specified by selection condition through a table, right? So there is a combination of selection and projection helpful to retrieve a data, retrieve database or data from an database, okay. So whenever I take queries, always we think of a combination of projection and selection to retrieve a data, okay. So here is selection and projection for retrieving data if required, right? For example, I want to retrieve the project number from a table. So I want to retrieve the project number, so working on project name called research. So I want to retrieve the project number working on project name called research, right? I want to retrieve that one. So that time, so I can specify R1. So I want to retrieve project name. So working for project name called, I want to retrieve project number, which is project name called research, okay, from table called project, So you want to first think about, when you go for tables, when you go for return of a database, first think about what is the question. So question is to retrieve the project number, the employees of, means I want to retrieve the project number working on project name called research. So when I tell project name and project number, I want to go with a database called a company database and see that which matches the table of requirement question. So there is an employee, there is a department, there is a project, there is a work zone, there is a dependence, right? So my question is retrieve a project number with condition called project name. So both is present in project table. So project table contains project number and project name. So I want to retrieve project number and putting condition project name from a table called project, That's what I done here. Okay, this is the combination of projection and selection for retrieving a effective retrieval of a queries, Okay, so next one. So next I will go to union, intersect and minus. So union, intersect and minus. Intersect and minus. Union, intersection and minus. Union, intersection and minus. So this is actually people are learning in various data discrete like DBMS data discrete mathematics. You have learned this union, intersection, and even through mathematics you learn. Same thing can be applied for relation algebra, okay, for union, intersection and minus. So I will go with a beautiful example that it has. So I will take two tables. So one is teacher, one is teacher table, one is teacher I will go with, okay. So teacher has first name, last name and age, okay. Something about, let's have 5 tuples, let's have 5 tuples. So maybe Steve, Smith, Sachin, Tendulkar, Rahul, Ravit, okay, Sharat Kumar, and Deepa Singh. So I have done here, taken a 5 tuples for a table called racer, table called teacher. That's some age of 24, 32, 33, 36 and 37. Okay. So I retrieved, just I take an example of teacher table, includes attribute of first name and last name and age. Then there is a tuple, right. So then I will take other table. Table includes again first name, last name and age, okay. So here we'll take this Kumar, so we take again Steve, Sachin. Then I include different because I want to go with the minus attribute, then I want to go with the different attribute. That's what I'll go with. Naresh Kumar. Okay, we'll go with Naresh Kumar. So here age may begin 24, 32, 62. Okay. So here student table and teacher table, student and teacher table. Just as take a part of example that required. Okay, example that required to be specified. So now union. So what do you mean by union? So union is to teacher union student. If I write a teacher union student, so I write it here itself. So because it's very easy to habit out, so I require this table to further continue. That's what I want to retain the table when I required. Okay, so here teacher union student, teacher union student. If I write like this, so teacher union student, if I write like this, then so Steve, Sachin, Rahul, Sharath, 1, 2, 3, 4, 5, 6 tuples will be retrieved. So I'll write, so if I write that one as a part of things, so I'll write it here. So first name, so last name, and each 1, 2, 3, 1, 2, 3, 4, 5, and 6. And 6 will be written, and 6 will be written, right? So as I told, it's a Steve, it's in Sachin, it's in Rahul, it's in Sharath, it's in Deepu, it's in Naresh. Okay, so all these tuples will be retrieved as specified. I can fill it out. Okay, when I go for teacher and student, so totally union. If I write as a union, then I can think of doing union, which includes both the sides. So I have Steve, Sachin, Rahul, Sharath, and Deepu, and Naresh. So Steve and Smith, Sachin will be repeated again. That's what I want to include only one time. That's what I included only one time. Steve and Smith, Steve and Sachin will be retained for only once, as it find 2 times, but I will let him retain it only one time. So Steve, Sachin, Rahul, Sharath, Deepu, and Naresh will be retrieved as 6 tuples will be retrieved if I go for union. If I go for an union, okay. If I go for a union, the teacher union student, okay. This is the one step where I want to go with the combination of both tables. There is a question, there may be a question that if I consider a database of company database, so retrieve the employee SSN, who work for department number 3 or department number 4. So I want to retrieve the employee names who work for department number 3 and who work for department number 4. So and so there is R, specify R, because union contains R intersect go for AND operations. So what I want to do it out. So I want to retrieve the SSN of who work for 3 or department number 4. So any can be possible. So working for maybe 3 or maybe 4. Okay. So that time I can write it like this. So R1 so contain SSN what department number 3 from employee table, from an employee table. So R2 SSN contains department number 4 from again employee tables. That's what we done. Again employee tables have been retrieved. So now what is my job? So our job is to do union, because they told the condition is R, where you want to retrieve the employees working for 3 and 4. That one I want to make it as a union of R1 union R2 contains by table called relation called R3. So R3 contains R1 as a relation and R2 as a relation from department 3 or department number 4. If a union of R1 and R2 with this relation contain R3, so R3 contains employees working for 3 or 4. So both will be included in R3, relation R3. So this is the best example for what you call as union. Okay. Now if I go for intersect, if I go for an intersection, okay. So hope you understand this R1, R2 and R3. Okay. So this is what union. So if I go for intersection, so would includes both teacher and student, Okay. So both teacher and students. So intersect. So both teacher and student. So here who both teacher and student, there is Steve and Sachin. So teacher is Steve, and Sachin. Here student is also teach Steve and Sachin. So only two tuples will be appear that contain first name, last name, and age. So here it contains, as I told, Steve and Sachin Smith 2432. Okay, so only two tuples that appears with Steve and Sachin, which is both teacher and a student, So if I condition same thing where I want to find this employees working for department number 3 and department number 4. So I want to find the employees working for both the departments. Then I want to write SSN. So R1, SSN, R2, so R3, so R3 contains R1 intersection R2. So R1 intersection R2 contains R1 intersection R2 contains R3. So R3 contains the employees working for both the departments, that is department number 3 and department number 4. Department number 3 and department 4 will be retrieved in a table called R3. So this is one condition where we talks about union, we talks about intersection. We talks about union and we talks about intersection. So now I'll talk about minus. So teacher minus student. So two things as I can consider. So student minus teacher and teacher minus student. Okay. So here, if I work on student minus teacher minus student and student minus teacher, so I want to find, so contained by teacher but does not contain by student, So Rahul, Sharath and Deepu does not appear in student table. So if I write for this, three tuples can be written. So first name, last name, age. First name and last name and age. Okay. So here I have to include Rahul, Sharath and Deepu, Kumar, Dravid, okay. So this is what this teacher minus student contains, where the tuples which are belong to teacher does not contain by student. That will be called as teacher minus student. So same thing here. So student minus teacher, student minus teacher, Okay. So here it contains, as I told, there is only one tuple because Steve and Sachin contain in teacher table. Only Naresh is present in what we call as student table. So it contains only Naresh, Kumar, 62. Okay, only one tuple that does not contain in teacher table. So it includes only student. Only one student called Naresh will be included in student minus teacher. Okay. So this is what in union, this is what intersect, this is what minus works. Okay, this is what how it works, very simple way, because I don't want to include any definition. This is what union, this is what intersect, this is what minus. So I am just including, I was telling that best example I have been shown. Hope it made you to understand. With student and teacher table. So where teacher union student include 6 tuples. Where you go with the teacher union student include 2 tuples. When I go for teacher minus student includes 3 tuples. Then when you go for student minus teacher includes only 1 tuple. So if they ask you write the operation of union, intersect and minus in exam, you take example, it's very easy to write out and describe the well so that anybody can understand what you written as an example part of things. So in DBMS, if you talk on more on examples, it's make you too easy to understand. Okay, it's not a theory oriented subject, it's a DBMS talks about more about practical applications, right? It talks about more about practical application. So union is included in SQL also, right? When you go for SQL, you want to union two types of queries, you can include this union and write a equation. So union works well in like MySQL softwares. Okay, so there you want to utilize that one. Okay, so there may be employees work on some projects, work for departments. They want to union both of the sections. That time we include a union operation. Union operation can be helpful for more and more operation that required in any of relational algebra or SQL. Okay, so next one. So this is what the union intersection minus defines. Okay, it's very important question for your exam point of view. Okay, next I'll move to Cartesian product. Okay, I'll move to and Cartesian product. So Cartesian product. So Cartesian product. Hope you remember again this one in mathematical operations you have specified, right? So again you done a Cartesian product of into, right? Into have been, so multiplication symbol have been specified, right? So now I'll take other example how to do the Cartesian product. So they like a two example, that is two tables. One is department, so D number, D name, SSN. So 1, 2, 3, so SS, YY, MM, 1, 2, 2, 2, 1, 1. Okay. So department table contains department number and department name and SSN have been specified. This is a table called project. So project contains project number and project name. So contain two types of project, 10 and 20, library and research. Library and research are two projects that contain by what you call as project table. So my job is to do Cartesian product of department into project. Department into project have been specified. Okay, department into project need to specify department into project. Okay, that is the Cartesian product I want to do for both the tables. Both the tables, right? So now if I write this, okay, so D number, D name, SSN, P number and P name, P number, P name. Okay, so because there is no common attribute between both the tables, so it is containing a department table, they contain project table. So if I go for multiplication, of both the tables, there is no common attribute between, because it contains department number, department name and SSN. The project table contains project number and project name. So there is nothing common attribute between both the tables. To join these two tables, I do not have any common attribute. That's what I want to go with, what I call as P number and P name with a D number, D name and SSN. Okay. So now if I do Cartesian product, what I may get? Okay. So department number 1, SS 111, P number 10, P name library. Okay, P name library. So again 1, SS 111. So I want to go with 2. So 11 with the 20. With the 20, I want to specify 20 research. 20 research have been specified. Okay, so then I'll go with 2, 2, I'll go with 3, 3. Okay, so required YY, required MM. Okay, so here I have 2, 2, 2, 2, 1, 1, 1, 1, 1, 1. So 10 and 20, 10 and 20. So library, research, library, research. So if I do for multiplication as a Cartesian product concern, so I can go with a project into department. So department into a project where I am doing my Cartesian product. So there is a 3, there is a 2. So 3 into 2 is 6 tuples must be appear if I do Cartesian product. If I do and Cartesian product. So 3 tuples are available. There is a 2 tuples are available. So 3 into 2 it becomes 6 tuples. So 1 will appear 2 times, 2 will be appear 2 times, 3 will be appear 2 times. So 1 1, so 10 and 20, 2 2, 10 and 20, 3 3 and 10 and 20. So here will be till B. So you can see that P number and D number will be primary key. There is one primary key because D number got repeated. So primary key cannot be duplicated as I told previous classes. So now is a P number and D number can be a key so that a uniqueness property can be appear in a both when you go for both composite key or a what you call as a key of combination of key makes uniqueness property. Okay. So this is the best example for Cartesian product. Take a 2 tables. So take a tuples, do multiplication with the one with how many tuples we have. So we have 3 into 2. So 3 2s are 6. So 6 tuple will appear if I go for multiplication of this tuple. You can see best example I can give it out. So there is a 1, 2, 3 and 10 and 20. So 1, 2, 3 and 1 with the multiplication 10 and 20, 2 with the 20 and 20, 3 with the 20 and 20. So multiplied all the tuples results have been appeared here. Results have been appeared here. Okay, results have been appeared here. Okay. So next thing is, so I will going to go to query, right? I want to retrieve the queries. So I want to work on this particular company database. As example I given as a real time example I taken there. So I want to also work on this database of company. Okay. So here my question is retrieve the dependents of and female employees. Retrieve the dependents of female employees. So I want to retrieve the employees of a what I call a female employees, not because gender may plays main role. So there is female employees I want to retrieve who are dependents, dependents of female employees I need to retrieve. So what I want to do it out. So I want to include 2 tables. One is employee, other one is dependents table. Okay, 2 tables I need to include. One is employee and dependent table I need to go on. So I want to utilize this Cartesian product as a part of things because without Cartesian product I cannot able to retrieve the female employees dependents. That's what I want to go with because there is no still not going to join. If they are to join, I can usually join by SSN using, but still we not moved join, right? We still in Cartesian product. That's what I want to utilize this Cartesian product to retrieve the female employees with the dependents. Okay. So there is want to include gender here in employee. So first R1 contains retrieve the SSN and name of a gender female from employee table. Okay. So the first thing I done is, so I want to take the SSN and name of a particular table that is called employee. So female employee, the condition is the given female. So I use selection condition, put a female and retrieve the SSN and name. Retrieve the SSN and the name. So retrieve the SSN, retrieve the name, gender female from employee table, from an employee table. So you got it, you got an SSN of an female employees with the name. Okay. What is next job? So next job I need to do the multiplication, right? Multiplication with, so R1 multiplies with dependents table. R1 multiplies with dependents table. So that is includes R2. That is includes R2. Okay. So R2 includes R1 multiplication with dependents. So R1. So better they will give some good examples so that how this works. It may clear clarity of the things. Okay. So R1 contains the female employees of a name. So this may be contained like this. So SSN and name, maybe 1 1, maybe 3 3, maybe 3 3 it contains by R1 maybe Pooja and what you call a Sharat maybe included, not Pooja because it's female employee, right? Maybe Shweta. So R1 table contains the SSN in name of two tuples, that is female employees SSN. So I need to search dependents. So dependents tables may contain like this. So SSN dependent name, then dependent relation. So maybe I have four tuples that contains, so 1 1 1 1 2 2 2, so then maybe 1 1 1 repeated 3 3 3. Okay, so this is details that contain in dependent table. I don't want to fill entire things as, or maybe it may be easier to find in dependent tables, in a dependence tables. Okay, dependence tables. So now I told R1 multiplication with dependence table. R1 goes multiplication with dependent tables. So R1 multiplication with dependent tables. So if I do multiplication, then R2. So R2, what R2 contains? So I'll multiply 1 1 with 1 1, 1 1 with 2 2, 1 1 with 3 3, 1 1 is again what 1 1, 1 1 with 3 3. Okay. So again 3 with a 3, 1 1, 2 2, 1 1 and 3 3. So 2 into 4, 4 2s are 8. So 3 2s are learned previously. It has 2 into 4. So 2 into 2 4s are 8. So 4 2s are 8 and 2 4s are 8. So 8 tuples will appear because 1 into 4 and 1 into 4. 1 into 4, total 8 tuples will be appear. So 8 tuples will be appear. So what is next job? So I got this particular table where the multiplication I done it out, but I want to find, I need to find, if I go from multiplication 1 1, this looks same, right? 1 1, this looks same. 3 3, this looks same. So 1 1 we have dependence. So 3 3 is a female employee, you have dependence. So 1 2 3. So these are the matching tuples with the SSN. If I go for the what I call female employee SSN matches with the dependence table employees. So I may find when you go for equal of things, I may find putting a condition, I may find equalness and can retrieve the female employee dependence. Okay. So now if I go for this continuation of this table, I want to retrieve name of the female employees where SSN, the R2 contains SSN. So R2 contains SSN equal to SSN. Maybe I'll include DSSN. We'll make it as a DSSN, so that is easy to confuse because both SSN. So SSN must be equal to DSSN from the table R2. From the table R2, name will be retrieved as a part of things is that employee name will be retrieved who are dependents. It is R3. It is R3. Okay, what I done here? So I join this one with the condition specified equal putting. So S1 DSSN. So it's equal. So was 1 is equal to 1 1. So totally 8 tuples are there. When you go for R1 multiplication dependence. When you go for multiplication with R1 with the dependence, I have 8 tuples. Okay. So this one matches this one. Okay. Does not matches here. This one matches this one. So 2, right? So 1 1 goes with the 2 2. So 2 tuples will be appear with the details of dependent name and dependent relation will be appear. Okay, will be appear. What are the retrieves? You can retrieve dependent name also. Okay, dependent name can be retrieved. So then 3 3 go with all this one but matches with the 3 3 here, right? So this is equal to this DSSN equal to SSN. So this tuple of dependent name Shweta will be retrieved. Shweta name will be retrieved with the dependent name. Maybe I will include Sharat. So Sharat will be retrieved because of Shweta's retrieved name called dependent name called Sharat. So Pooja may have so Bharat and Arun. Okay. So when Pooja matches, so 1 1 with the 1 1 matches, Bharat and Arun will be retrieved. So totally Bharat, Arun and Sharat will be retrieved as a part of dependent names for Pooja and Sharat. Okay, by matching with SSN with the DSSN. Okay, so this is what how the Cartesian product works. This is what how the Cartesian product works. Okay, very simple. We started with the union. I shown intersect. I know shown how the minus works with a fantastic example and fantastic with a company database. So Cartesian product, we taken two tables, project and department table, do the multiplication. I shown it out. Then I go on the company database. We taken R1 as a part of things is, so a female employees, then I come with the dependents where it matches with SSN with the DSSN. If both are equal, I am retrieving the query called what I call as name on depend name. So Pooja has one depend, two dependent, Shweta has one dependent, will be retrieved in a table called R3. Hope I made it to clear understanding of that requirement. So practice this whenever free, whenever people are free, try to see the video as much as possible till you understand that. So first time it's very feel to, because relational algebra is very easiest one, but unfortunately people feel difficulty because of utilizing the symbols that provided by relational algebra is very difficult task. So understanding relational algebra is another difficult task, but as I know, as I started the DBMS, initially I was thinking, how to teach this one. But when I go on teaching this one, I felt very easy in relational algebra. Best you want to think it out. So this is the equation I want to utilize. Because in exam, they may, as a model-wise concern, they may go with R condition for relational algebra and SQL. So you can choose anything relational algebra or SQL. But if in the future you want to go with MTech or higher degree with the NET exams you want to write or KCET exams you want to write, make sure that you people are involved in such a things as where you can write and you can learn it out more things as. Okay, so their relational algebra is more required. Okay, so thank you so much. In next class I will teach joins like what do you call it, like natural join, theta join, equi-join, outer join. Okay, then we can go for division and aggregation and what I call as grouping. Okay, so then relational algebra combines with a one or two experimentation, we can club and finish up and move to SQL. Okay, thank you so much.